Hi, and welcome to this flipped instructional session. I am Mrs. Fessel, this is Earth Science, and today we're going to talk about Lesson 5.02, Landforms. In order to get some background on landforms and how they form, we need to review the parts of the Earth. So the crust, up here, is the top layer of the Earth's surface. There's two types of crust, oceanic crust, which is thinner and denser, which means it's heavier, and the continental crust up here, which is what the continents are made of, is thicker but less dense. The crust is constantly being created and destroyed, and oceanic crust is moving a lot more than continental crust. So these two layers, top layers, the crust and the uppermost solid layer of the mantle, are known as the lithosphere, and that is what the tectonic plates are made of. Below that, we have the asthenosphere, which is part of the mantle, but it is very different. It is superheated plastic-like rock that actually flows, and that is what the tectonic plates are moving on. So here are the tectonic plates. They are constantly in motion. Our Earth is constantly moving. Sometimes they're moving towards each other, sometimes they're moving away from each other, and sometimes they're moving in opposite directions and grind against one another. And those different motions of the plates are what we're going to talk about today. So here we have the crust boundaries between plates. We have convergent boundaries, the base word converge, telling us the plates move towards each other or converge. Divergent, from the base word divide, tell you that the two plates are diverging or moving apart. Then finally, in a transform plate boundary, the two plates slide past each other in opposite directions. And different things happen at each of these different types of boundaries. So first we're going to talk about convergent boundaries. This is where both plates move towards each other. And there are three main types of convergent boundaries that we are going to talk about today. The first one is an oceanic continental convergent boundary. This is where land meets water. Oceanic crust, as we mentioned earlier, is denser than continental crust. So it sinks into the asthenosphere through a process called subduction. Sub meaning under, telling us that the oceanic crust is going under the continental crust. So as it sinks, it melts and makes a magma chamber. That's what's happening right here. The magma is less dense and rises, so this forms volcanoes and volcanic mountains right here. It also forms a trench or a V in the Earth's surface as one pulls underneath the other. And finally, there can also be earthquakes as one piece of crust slides underneath the other piece of crust. Next, we have a convergent, this is the same one, the convergent boundary where land meets water, and here we also mention the trench, when the oceanic crust sinks underneath the continental crust. An example of this type of boundary is the coast of South America near the Andes Mountains, and this is actually how the Andes Mountains formed. Next, we have oceanic-oceanic underwater collision. So this is where two oceanic pieces of crust come towards each other. One of the plates is going to sink, most likely, slowly going underneath the other. So as you can see, we get underwater volcanoes as one plate melts, trenches right here as one plate slides under another and forms a V, and if the volcanoes grow large enough, they can form volcanic islands. An example of this is the Tonga Island chain formed when the Pacific Plate and the Australian Plate collided. Another example of an oceanic boundary is the Marianas Trench. So this is the deepest point on Earth. Challenger Deep lies 7 miles below the sea level, and this is occurring as the Pacific Plate right here goes underneath the Eurasian Plate, and it is forming the deepest trench on Earth. Then finally we have a continental-continental collision. So this is as two pieces of continent collide into each other. This kind of a collision occurs gradually, but because of the large land masses, there's a lot of energy involved. The two pieces of crust move towards each other, and they crunch up, like two cars crunching into each other, folding and bending to form tall, rugged mountains. The most famous example of this is the tallest mountain range in the world. The Himalayan mountains are forming in this way, as the Indian Plate crashes into the Eurasian Plate. So those are our convergent boundaries, or plates coming together. Next, we're going to talk about divergent boundaries. So this is two plates moving away from each other. And this most likely is going to happen between two oceanic plates. A great example of this is the Mid-Atlantic Ridge, because this is two oceanic plates moving away from each other. As the plates separate, they create a space that may fill with magma and create a ridge or underwater volcanoes. Because as the plates separate, magma comes up and fills the gap. The Mid-Atlantic Ridge formed in this manner. Not as common, but two pieces of continents can pull apart as well. So this may cause the crust to split apart. In Africa, the Rift Valley is the divergent boundary between the Somali and the African plates. So the Red Sea is also gradually getting larger as these two plates pull apart. Here's an example of the Great Rift Valley in Africa and the Red Sea. Both of these are occurring as these two plates pull apart. Next, we have a transform boundary. So this is our third type of boundary. The plates slide past each other in opposite direction. So the North American plate is moving more downwards, while the Pacific plate is moving more upwards. This is where most likely the biggest earthquakes on Earth will occur, because as the plates move, pieces of the crust stick. As the plates slide past each other, pressure can increase. And as the pressure increases, they suddenly slide past each other, and there's often a violent movement. This causes earthquakes on the surface above the plate. An example of this is the San Andreas Fault along the coast of California, which we just saw. So here you can see that this is the San Andreas Fault right here. And you can see that this river used to line up, but because of an earthquake and the plate sliding, the river no longer lines up. All right, so our last example is a hotspot. So this isn't due to the plates moving, but this is volcanic activity within a plate. Hot, molten material rises from the mantle, melting the crust above it to form volcanoes. So the most famous example of hotspots are the Hawaiian Islands. And the volcano that is forming the Hawaiian Islands most recently erupted. You may have seen it in the news a couple months ago. And the Big Island is located directly over this hotspot. So that's the end of this recording. Please look for the flipped follow-up in your Class Connect schedule, and I hope you have a great day. Thank you. Bye.